Good morning, everyone. I'm Ruwini Edirisinghe. I'm presenting the machine learning based urban vegetation carbon model my amazing team developed. So we have Bhavantha there, Lahiru, and Shane in my team. So literature reports that urban systems generate 70% of global greenhouse gas emissions. Urban trees, parks, and green spaces actually absorb carbon from the environment, but we really do not know how much is absorbed and where across the city this absorption happens. So because of this reason, it creates a significant evidence gap in carbon accounting, urban greening, and climate resilient planning. So net carbon accumulated in vegetation happens after photosynthesis process and respiration. So that is the proxy we used in this study, which is called net primary productivity, or NPP, to estimate the vegetation carbon sequestration. So MODI's satellite data at NPP has NPP, but that's really good at large scale forest and regional areas. However, this 500 meter resolution is not sufficient for urban scale finer analysis. So what we did here is we used machine learning algorithms to link this 500 meters coarse data, NPP data, into finer resolution level predictors like 10 meter level predictors. So basically our study area is Melbourne metropolitan area, and you can see the complex methodology we use. I'm not going to go into details, Matt, to save time, but I'll be giving you highlights of the major steps today. So these are the data sources we used. MODI's NPP as the target variable, but Sentinel-2 data we used at high resolution spectrum data, and we used 3 vegetation cover types: land cover, dynamic world, MODI's land cover, and vegetation cover, including tree density as well from WICMAP dataset. Well, we did general data processing. Sentinel-2 data was pre-processed, and also structured vegetation data available as a polygon data set. We rasterized them to be in line with satellite pixel data, as well as to feed into the machine learning model. So these are some of the predictors we looked into. So vegetation indices NDVI and EVI gives details about an estimate about the photosynthesis capacity of vegetation. So that was used, and also obviously land cover details, as I mentioned. And structured vegetation data included tree density, grass cover, shrub cover, and 3 different classes of tree heights. So this slide shows the feature important analysis we did to understand how different predictors are significantly important in addition to the Pearson correlation analysis. So these are the predictors that came up as highly significant. Well, we developed 15 different predictor combinations. And initially we used a statistical model, regression analysis, and then used 3 different machine learning algorithms, random forest, gradient boost, and XGBoost. And model configuration 10 with random forest shows the best accuracies, and this also shows the regression matrices we used. Well, this is the final carbon vegetation model which shows the best accuracy, random forest model. Finally, well, what's the impact? So we aggregated the 10 meter data into SA1 level aggregation for neighborhood scale assessments. I think I'll go to the next slide that shows that. Yeah, so that's SGS SA1 level aggregation. And then Also, council level carbon aggregation can tell us more details about carbon accounting related to, for example, local councils. And just before that, I wanted to say the third objective we haven't yet achieved, but we can use this as a longitude. If we have the longitudinal data, we can use this as a benchmarking tool for planning decisions as well. Finally, future works. We have a lot of ambitious future works here. So one is we are in the process of validating this data set externally to hand over to AURIN. So we are in the process And national scale implementation is another future work. And also, in order for this carbon sequestration model to be completed, we are going to include soil carbon as well. Finally, integrating with other urban data such as energy. Now, thanks to AURIN, they've given us mobility data and also heat-related data that Shane is doing. So that kind of combination can create more scalable, validated platform for integrated carbon intelligence decision making. So that's it from me. Thank you very much. Stay tuned for more information.